I want you to start by taking a look at the top of page 194. Okay, what kinds of things automatically start to jump out at you? What kind of things jump out at you? Parker?
What jumps out at me is like on the example, there's
Okay.
there's 2 to 4 to 5 lines of
Okay, there's examples.
say you could say lines on paper, in more steps.
Okay. Well, let's start with this. Okay. Could I have Lexi please read number 1 there, where it starts with the word define? Oh yeah. Well, that's not going to do you any good. No, we'll wait. All right. Example number 1.
Define a variable and write an algebraic expression for the targets $10 plus $5 times the number of roses ordered.
Okay, that's great. All right. So what they want you to do is write an expression $10 plus $5 times the number of roses ordered. Okay, so let's go ahead and write that down on our paper. $10. Okay. Then it says what? Plus what? What comes after $10 plus $5? Plus means addition. Then we have this $5. Okay. Times the number of roses ordered. In this example, what are they using to represent the number of roses ordered, Millie? Yeah, they're using n, okay? However, what are they doing with n? Are they multiplying, dividing, adding, subtracting? Yeah. They're multiplying. And they're multiplying the number of roses ordered by what? What's it look like in the book? 5. Very good. So we'd have 5 times n. Now, we can rewrite this a little bit. Let me zoom in so it's a little bit closer. We can rewrite this a little bit without the number sign as 10 plus 5 times n. What did they do in the book to simplify the 5 times n? What did they do? Yeah, Savannah? They did 5n. They kind of combine them, don't they? So we have 10 plus 5n. All right. This, ladies and gentlemen, is called an expression. Notice that it doesn't equal anything yet. Okay? But what we're going to do is we're going to kind of break off from this a little bit, and we are going to say, what if it did equal something? Okay, so this is where we're going to get into our lesson for the day. Okay, so this is kind of where, oh yeah, awesome. You know, kind of how it just kicks off like that. It's my fave. Yeah. Yeah. You can turn off the light above the screen if that would help. There it is. All right, here we go. We have 10 plus 5n equals 70. All right, so take a look at this, ladies and gentlemen. Right now, we're just brainstorming. Right now, we're just going to ask ourselves a couple of questions. First of all, what is it we're trying to solve for if we are going to try to solve this equation? Yeah, we're going to try to find n. Okay, so I'm going to highlight n, just kind of like they do in your book. They highlight something they want you to focus on. So I'm going to highlight n. That's what I need to get by itself. However, we have 2 things happening here. We have 2 operations happening. Can anybody identify the 2 operations happening on the left-hand side? I'm going to draw my line here. So over here on the left, this is the right. Okay, on the left-hand side, which 2 operations are taking place? Anna? Okay, addition and multiplication are taking place. So we have addition and we have multiplication. Does anybody not see that? Please say so now so that so I don't move on and leave you behind. No, I'm just asking, does everyone see that addition and multiplication are happening on the left-hand side? Okay.
Is that how many to write on that side?
Not yet. No. Make sure you're leaving enough room. All right. So the question that I have to ask you is this: what is the opposite operations of addition and multiplication? Yeah. Okay. Yep. So subtraction is an opposite operation. I'm just going to put sub. And division is also the opposite operation to multiplication. So to solve this problem, our rules still apply, but it's just going to be 2 steps. So instead of doing one opposite operation, we're going to do 2. Okay? We're going to do 2. Now the question you have to ask yourself is, which one do I do first? And ladies and gentlemen, it makes a difference. And the answer to that question is always the one that's not attached to n. Whatever's not attached to n, we try to get rid of first. Okay, so looking at this 10 plus 5n, which one is the least attached to n? Yeah, Macy? 10 is, absolutely, very good. All right, so I'm going to scroll down a little bit. I'm going to rewrite this. So we have 10 plus 5n equals 70. Okay, I want to get rid of the 10. I know I'm going to either do subtraction or division. What am I doing with the 10? Am I adding it to something or am I multiplying it by something? Millie? I'm adding it. So what would be a good opposite operation to remove it? Oh, someone said it. Yeah, subtraction. Very good. So to get rid of the 10, I have to subtract. So let's go ahead and do that. Let's walk this through. I'm going to subtract 10 here, but the golden rule states that I must do what?
Cancel.
It will cancel, Parker. That is correct. But I also must... Very good, Jacob. Whatever I do to one side, I must do to the other. And very good, Macy. Okay, so here we go. So Parker's correct. They are going to cancel out over here. Okay, and I'm going to be left with 5n equals, what's 70 minus 10? Macy, 60. Now, that was step 1, removing the 10. Using one of our operations, in this case, subtraction. Now we're going to go on to step 2. I'm going to draw a line carrying our answer up here, 5n equals 60. And we're going to go ahead and we're going to do step 2. We use subtraction. What do we have left to use? Division. Okay, so we're going to go ahead and use division up now. And I'm going to divide what on both sides so that I can get n by itself. Macy, I'm going to divide both sides by 5. Okay, whatever I do to one side, I must do to the other. As a result, Parker Morey's idea of canceling out comes in play again here, and these 5s cancel out on the left-hand side. So therefore, I am left with n, and that equals 60 divided by 5, which does anyone want to take a guess at what that might be? Millie?
Wait, no, not 4. Not 4. There's wrong one.
12. Very good. And that is the correct answer. Now, I went through this slowly, asking lots of questions and getting lots of input. Okay? When you do this on paper, you will be much more efficient and I would guess it won't take you nearly as long. However, I would like to go through 2 more examples of this, just so you can get the idea down. Okay? All right. So, one of the things that is really important when doing this is order of operations. And so let's look at another problem this time that's a little different. Okay? Where instead of solving for the variable, we know what the variable is and we have to plug it in. All right? So let's go ahead and do this. All right, here we go. We are going to do n times 3 over 4. Okay, n times 3 over 4. And I'm going to tell you right now that that equals, let me come up with a number in my head here. Hmm.
28. 21. Hey, that was a joke.
Let's go with 9.
28.
Okay.
Wait, but it's 28 minus
21.
Yes.
Actually, let's change this a little bit. Let's not know what this is, and let's say that n equals 9, okay? And I'm asking you to evaluate this. Evaluate means to what? What would you do if you saw that you were supposed to evaluate this? What were you going to do? Okay, we are going to plug in what we know, what we've been given. What have we been given? N, and that equals what, Noah Miller? N equals 9. So how could I rewrite this? Okay, Savannah?
9 times 3 over 4.
Yeah, I could write this as 9 times 3. Okay, so I'll do this 9 times 3 over 4. And then I'm going to put a question mark because I still don't know what that is. Now, what am I going to do first? Am I going to multiply the numerator, or am I going to try to divide everything by 4? Yeah. Yeah, let's multiply the numerator first. Okay, get it one number, and then we can divide. So the first step here would be to multiply. Again, this is a two-step problem. We're going to have to multiply, and then what are we going to have to do? We're going to have to divide. So the first step here is multiplying. So I've gone here. Okay, now I'm going to go here. And 9 times 3 just seems to be slipping my head. What is it? 27, fantastic. 27 over 4 equals something. Okay, we did a multiplication. Now we're going to do division. Okay, and 27 divided by 4 would be, Savannah?
Do you want it in the fraction?
I would like it as a decimal.
Oh, I know this. It's 6.75.
6.75. And that's our answer. How many of you feel comfortable that you could plug a number back in and do 2 steps to solve it? Everyone? Anyone? Okay, a couple?
What work do we have to show for this?
All of this. Oh, yeah. You can't. So how many of you don't feel like you could, in this problem right here, plug 9 in, multiply, and then divide? You don't feel like you can do it? How many of you feel like you can plug one number in, multiply, then divide? Okay, let's do another example. Hopefully we'll get some more people on board here. All right, in your book, if you would please, turn to page 196. Okay? In your book, look at problem number 15. Okay, actually this is on page 197. Okay, I'm going to look at problem number 15. They have 12 minus 3b. We don't know what that equals. Okay? And they want you to evaluate it using this. And they put a little semicolon here. And they put b equals 4.3. Okay? So the question on the table is, what do we do? What do we do? How do we evaluate 12 minus 3b if b equals 4.3? All right, we're going to plug it in. So, your work on your paper should look like this. Please follow along. You would rewrite the 12, you would do a minus 3, and then what we find, and what as teachers we have always encouraged students to do, is to put whatever you're plugging in parentheses. The reason for this is that way when we look at your paper, we can see if you've made the proper, what we call substitution. Have you taken and replaced the b with the 4.3? Okay, this is very easy to see that yes, indeed, the 4.3 took the spot of B. Okay, and now we can move forward. What two operations are going to need to take place to solve this? Savannah? All right, multiplication and subtraction are going to take place. I'm going to write that down. Multiplication and subtraction. Now, according to order of operations, which one comes first? Multiplication or subtraction? Gabby?
Multiplication.
Indeed it does. If you look at the screen, you will see that multiplication comes first, subtraction comes second. Okay? So I'm going to multiply first and then subtract. So the next step in this process would be to simplify the multiplication. So I'm going to write my 12 again. I'm going to put the minus sign. And then I'm going to do 3 times 4.3. What does that equal? 3 times 4.3. Hannah Harvey. What does that equal? 3 times 4.3. $12.9. Very good. Okay. Now we do subtraction. Okay, and what do we end up with here? We are going to subtract these two, because that's what needs to happen second. You take 12 and you subtract 12.9. So you have what left over? Is it going to be positive or negative? It's going to be negatives because we're subtracting a larger number. And Mackenzie Berg? Yeah, it's going to be a negative 0.9. And that is the correct answer for this problem. Okay, so we did multiplication, then we did subtraction, and we solved it. The answer would be negative 0.9. All right, ladies and gentlemen, this is the first step in this process today, okay? Writing equations, figuring it out. All right, I want to take a look at one more problem, and then we will I will put your homework up on the board. Take a look, please, for number 11 on page 197. Isabella, would you please read that statement for us? All right, say it a little bit louder because we want to hear all about these chickens. 8 pounds less than 5 times the weight of a chicken. Oh, that is fantastic. All right, first things first. All of these problems are going to want you to have two operations that take place. So the first thing that you need to recognize, especially on this homework, is that you're going to have two operations take place. Okay, two. So of the multiplication, division, addition, and subtraction, you're going to have two that take place. So the first thing you should do is try to identify which two in the problem they're going to be talking about. Lexi? Yes, less than means subtraction. Okay? So 8 pounds less than 5 times the weight of a chicken. Okay, so we've already identified two of the operations. Now we just have to figure out how it all comes together. You should also, kind of try to start looking at, which numbers am I working with? Well, I'm working with the number 8. I'm working also with the number 5. Okay. So 8 pounds less than 5 times the weight of a chicken. Okay. There's always going to be a variable. What is the main subject of this expression? 8 pounds less than 5 times the weight of a chicken. Yeah. The weight of the chicken. And can you guys think of a variable that might work well here? W works well. I like it. Okay, so we're going to go with that. So I'm going to go ahead and underline weight of a chicken, and we're going to say that's W. All right. So 8 pounds less than 5 times the weight of a chicken. Okay. Can anybody think of a way that we could write this? Okay. Macy.
8 minus 5 times W equals.
Okay. 8 times 5. Oh, sorry. No, you're right. You're right. You're right. My bad. My bad. Okay. 5 times W. Now, with subtraction, and it's the reason I picked this example, it's tricky. Sometimes you have to go back and ask yourself, does this make sense? This is a very good start, but are we going to be subtracting 8 pounds from the total? Are we subtracting the weight of the chicken from 8 pounds? So think about when I read this again, listen carefully. We are going to have 8 pounds less than 5 times the weight of the chicken. So am I removing 8 or am I removing 5 times? What do you think? Listen carefully one more time. 8 pounds less than 5 times the weight of a chicken. So think about it in terms of this. Mr. Bornheimer is 8 pounds less. Did I subtract Mr. Bornheimer from 8 or 8 from Mr. Bornheimer? Lexi. Okay. I lost 8 pounds. So I subtract 8 from Mr. Bornheimer. I wasn't going to point it out. Jeez, you guys are cruel.
Well, it was so obvious because then you said you were taking 8.
Okay,
I was
no, that's okay. I would expect confusion with the subtraction. What I'm going to tell you is this, okay? This actually should be written as 5W minus 8.
Well, that's not what it looks like on your thing.
You're right. That's not what it looks like in the statement. And with subtraction, the way that they write it, this is where the English language comes into contradictions with mathematics. Let me tell you. Just so you all know, it took me a long time to learn this. So I'm not expecting you to be masters of it today. So please know that's not the expectation. We're asking you to try it. What am I asking you to do? Yeah, try it. Well, you get completion points for trying it, do you not? Every day when I grade your homework? Well, very few people have ever gotten an F on my quizzes. Very few. Okay? So, usually with subtraction, we switch the beginning and the end. But you should always go through and replace the words with symbols, variables, and numbers. Okay? The reason that I'm recording this is so you can go back and look at this again. Would you like to see one more of these?
Yeah.
Okay. Let's look at one more. Let's look at one that's in your homework. Let's look at number 12. Number 12. Okay. I'm going to have Mackenzie Berg. Would you please read it? 12. Okay. Let me rewrite. I'm writing it out here. Plus 100 miles. Okay. Remember, each of these problems is dealing with 2 different operations. Okay? 2 operations. Which operations are we dealing with here? Millie? Okay, very good. Where it says twice, that actually indicates 2 things, doesn't it? Multiplication, and then what number? 2. So whatever we're doing, we're going to be multiplying by 2. That's actually what the word twice means. Multiplying by 2. Okay? I went twice. I went 2 times. Get it? 2 times. Twice. We have actually taken the word 2 times and made it twice. Okay? All right. So, twice the distance in miles flown last year plus 100 miles. Where's the other operation? Gabby? Oh, indeed it is. It's right here under plus. Okay? Now, we've already got 2 in there as part of our number. Are there any other numbers involved here? Okay? Yeah, 100. Very good, Macy. So 100 right here. And then, of course, the 2 up here. And then the last thing we have to identify is a variable. Okay? What is the main subject? All you English folk out there, you're kind of identifying what are we talking about here? Yeah. Distance in miles. So what variable could we use? D, absolutely. We'd use D here. That would be a great variable to use, D. So we have twice the distance. So we have 2 times D plus 100. And this one, as Macy so eloquently pointed out last time when she read it in the previous problem, is exactly as it would appear. It's 2D plus 100.
So this one
When it
supposed to be.
Yes, when it comes to addition, addition's not tricky. Addition, when you see the words plus or add, you can basically just do this. You identify the pieces and put it together. This would be a great answer. I will tell you, number 10 is subtraction. So right now, just in the margin of your notes, write, okay, be careful with number 10. Okay? And number 8 is subtraction. So be careful with number 8.
So wait, so 10 and 8?
10 and 8 are going to be tricky. 10 and 8 are going to be like 13. You're going to have to switch it when you're done. Okay? You'll be fine. You'll be fine.
Can you do all of our homework with us? Wait, how was the answer 2D plus 100?
Twice the distance in miles flown last year plus 100.
But you
So,
don't solve it? But you didn't solve
no, that's it. No, that's all they want you to do.
it? Oh, I solved it. I got D equals 50.
I don't know how that's possible, but great work. Great work. I appreciate the enthusiasm.